So hi everybody, welcome to the fourth webinar in the AWC3's webinar series about watercourse crossings. My name is Daniel Monaco and I'll be acting as your host for today's webinar. Just before we get things going, usually last time I did this at the end, but we'll try it today at the beginning and see if that works out for us. So it's just a quick poll to find out where everybody's affiliations are. So let's just launch that while I do my intro. So before getting into today's webinar, just wanted to give a brief introduction to AWC3 for anybody who this is your first webinar in the series. So AWC3 is a not-for-profit organization whose primary objective is to facilitate information transfer around the issue of watercourse crossings in Alberta and their impact on native trout species. So this is what this webinar series is all about, is sharing information from subject matter experts and trying to get that information out to as many people as possible. So since we have received some questions about this, I wanted to let everybody know that this webinar can be used for continuing competency credits for professional associations. So it counts as half an hour of credits and has been approved by most major professional associations. So if that is something you are hoping to take advantage of, please keep your receipts and your registration confirmation email. And if you have any questions about this, you can email info@awccc.ca. Today's webinar is about construction best management practices, about culvert removal, stream restoration, and we have Steve Acorn from Acorn Environmental. So to give a bit of a background on today's presenter, Steve has 20 years of operational experience in land resource management. Steve's career has focused on civil earthwork construction, remediation excavation, frac water management, and stream crossing installation, reclamation, and rehabilitation. Steve currently contracts to one of the largest oil and gas producers in Western Canada as a senior supervisor, managing and executing civil earthworks projects and stream crossing projects. So before passing things off to Steve, I just want to let everybody know, if you have any questions throughout the presentation, you can submit those through the questions window in the GoToWebinar program, so the toolbar that appears on the right side of your screen. I will be compiling these questions from the chat throughout the presentation, and we'll go through those once the presentation is finished. I would also ask that anybody asking questions, that those questions stay relevant to the topic at hand. And if they're out of scope, we may not get to them in this presentation. So without further ado, I'll pass things off to Steve.
Thanks, Daniel. Welcome everybody to today's webinar. Today's webinar, I will be concentrating on construction on stream crossing restorations. To start, I'm going to play a little video. So while I introduce myself, we can watch this video. I grew up in the Yellowhead region. I happen to live along the McLeod River, so I've got quite a bit of interest in streams. I'm an old college graduate. I started out in industry primarily as a heavy equipment operator when I was younger. That led me into civil earthworks. Civil earthworks, I've also been involved in installing new crossings, and that also led me into creek restorations and stream crossing improvements. The presentation is going to be primarily focused on construction from an execution perspective. How do we take crossings that are issues and improve them with both construction practices in mind as well as ecological? The outline for my presentation will be divided into 4 pieces. We'll start with planning, preparation, execution, and monitoring. When we talk about planning, I'd like to divide this into 2 groups, high-level planning, site-specific planning. Planning can be influenced by many different things. What we've seen in the past is a lot of the fixes we complete are based on emergency fixes. So they're reaction-based, compliance inspections. We all know that can be costly and they become ineffective when we just are talking about restoring our creek. We want to shift the focus to priority fixes that concentrate on watersheds, species in different water basins, they could be driven by area-based closure plans. If we can also think about areas, we can concentrate on road infrastructure, stream-based, and collaboration with other operators. So high-level planning, we've had some previous webinars on inventory that Jordan presented last week. I think most people are familiar with the process. So as an operator, whether you're an oil and gas company or a forest company or a mining company, you can, once you've got your inventory collected, there's a lot of tools we can use to look at your specific crossings. You can prioritize those, whether you're looking at operational areas or ecological areas, and you can decide on whether you're going to do small projects or large projects. Consideration should be taken into account for your fields. For example, if your field is a new field that has a 50-year life cycle, you're going to a new cut block area, you may want to make sure you're installing crossings that are for 50 years. If you're going to a field that's older and getting close to reclamation, some of the crossings, you may want to look at some area-based closure plans. Of course, one of the complications with crossings is budget. So budgeting is part of the higher level plan. What I'd like to do is look at a zoomed in area. So say you're an operator and you have taken your inventory, you've identified that you've got some red crossing priorities, some orange ones and some green ones in a specific area. When you look at that area, you've identified that of your 20 red crossings, only 4 of them are really on an important creek. So in this particular example, say you've zoomed into these 5 crossings. There's 5 culverts on 2 creeks in one area and multiple roads, and your goal is to do a stream bed restoration. Typically, when you look at these, you'd think, okay, I've got 5 crossings to fix here. My budget is, you look at the site plans, you understand that you have a budget for each of these, and you are going to try and execute these. If you zoom out, it's sometimes nice to zoom out and look at these from at other crossings in the area. So what I want to do is look, if we start at the bottom left, we'll follow my highlighter. We've got 3 crossings on one road. And if you go to the downstream side of this, you've also got an unknown crossing. So that crossing was not identified on your plan. And when you look into the information in the creek, maybe somebody else has a crossing there that is damming off the creek. In the middle, you look at your individual site plans, and this is a complicated crossing. So if this is a bridge and these 3 crossings on a road, and this is somebody else's crossing, by fixing this bridge and fixing these three crossings, are you going to achieve the objective of opening the creek upstream? Here's another way to look at it. Your 4 crossings are still on here. You've now talked to the third-party owner of this crossing and identified that perhaps we should do this, fix these crossings in a group. Your complicated crossing that was potentially a large bridge and a huge budget, can we look at alternative measures to fix that? So when I look at this particular site, there's 3 wells that this road is accessing. And instead of fixing this crossing, can we look at installing a new road that's potentially cheaper, restore this crossing 100%, which removes the long-term liability. It also reclaims a large riparian area around the creek. When I look down in this area, on the bottom left, why did we have 3 crossings in 800 meters? So historically, you may ask that question and blame it on planning, but at the time of this installation, it was maybe overlooked why we have 3 crossings in one area. They simply put 3 culverts in, and now we have 3 barriers. So instead of repairing that barrier, that barrier, that barrier, installing 3 new crossings, can we look at keeping the one that has the high access requirement, potentially removing these 2, and bringing a road in from an alternative location? By looking at this from a larger perspective, we can not only restore this entire creek by working with others, but we may significantly reduce the budget and become more efficient and remove crossings on the entire creek. So the result of this is, prior to us starting on this creek restoration program by ourselves, even if we would have fixed our crossings upstream, we would have still had a barrier downstream. So we've done all this work and not actually restored habitat upstream. By working with another operator and ourselves, we can now look at fixing their crossing, removing this crossing, exchanging footprint from a riparian area to an alternate route, installing a new crossing here on a high access road, removing this crossing, as well as this crossing, and having a new access road coming into the well here. And the end result is we've now opened up the entire length of the creek. So site planning, the key about the higher level planning is it's not always, you can always look at, you should look at it from a larger perspective. Instead of looking at each individual creek and thinking about fixing each individual creek, can you change an area to reduce the amount of crossings in that area? Site planning, when we go into site planning, a lot of this information comes from the inventory you've collected. So Jordan had a good presentation where they will collect information on the location, on the creek classification. You'll understand the watershed priority. You'll understand your existing conditions or issues. The site planning, or the site-specific planning too, you also want to understand your details of each crossing, the watershed and peak flow for an area. So if you've got an existing culvert that is undersized and you've identified you want to install a larger culvert, make sure you consider the Q25, Q50, and Q100 flows, so you're installing the proper culvert. This can be done a variety of ways. LiDAR modeling is a very good method. LiDAR modeling can collect data on watershed areas, slopes, and predict water velocities and volumes through each crossing. It's also important to understand the stream gradient, width, and stream bed features, topography features for an area, the slopes, and road grade, depth, or fill to your crossing. The aquatic details, some of this will also be included in Jordan's inventory, or the inventory you've collected. There'll be more detail on this in a webinar in the future. So now that you've got your site plans, you know where your location is, you understand the creek characteristics, you understand your aquatic characteristics, you know you have a problem, you can determine your solution. Solutions can be a variety of solutions. We can look at bridges, alternative box culvert crossings, arches. You may be installing a culvert. But today we're going to talk mostly about restoration. So restoration, we're talking about restoration of the creek to rehabilitate habitat upstream. If you decide to install a new crossing over this, we still need to restore the creek first. Preparing for a project, I've broken this into two things and we'll skim through this fairly quickly. Permitting and approvals and contractors and materials. So permitting approvals, most of the creek crossings that you are going to repair, if they're fluvial, involve the Code of Practice for Watercourse crossing notifications. These will be required whenever your stream is fluvial and fish or potentially fish bearing. If you're working in or near the water, you'll want a good quace assessment. The COP notifications can take up to 14-day process. Your COP notification will include your best management practices. And if you're doing a program like we showed earlier in the presentation, you can group your COPs for multiple sites into one notification and include your best management practices. Preparing for your sites, with all this information, you're going to come up with a design or a plan for your site. So if you are looking at installing a new bridge, you may have a complicated engineered drawing with top topography features, bridge specifications. If you've got a large cut fill, you might want to do some LiDAR data, come up with some cut fill plans. Your creek itself, you want to have a plan for how are you going to restore your creek, what it's going to look like, and the alignments and features you're going to install, whether it's under a bridge or under an arch or a complete restoration. Considerations in your planning or preparing for a site is temp workspaces. So if you've got a large, complicated site that you require workspace outside your right-of-way, you may require a TFA, or now called RTFs. You may require storage areas for, if you've got a large excavation, to remove some of the material from the site, or a bridge laydown yard, or your aggregate delivery. You may want to collect trees for your restoration program, and you also want to think about water discharge locations. All this will require approval, and it may also require First Nations consultation if you're over 0.5 hectares. You want to think about your third parties in the area. So you may have a power line or a pipeline or road use. If you're going to close the road, you'll want to think about road closure signs, road closure notifications. Is there a program going on that requires access to your site? And I've highlighted this one in red too, ground disturbance permits and pipelines. A lot of the creeks that we are looking to restore are going to be historical from the 60s, 70s, and 80s. And a large portion of the time, there could be pipelines adjacent to the right-of-way that will need consideration as well. I recommend looking at ground disturbance up to 6 months prior to your excavation to understand whether you've got pipelines in the area or not. You may need to look at an abandonment process. Contractors and materials. So once you've picked some sites, you need to think about the materials you'll need for that site. Are you installing a bridge? Are you installing a culvert? Are you installing an arch? Any of these items, you'll be working with contractors. Bridges and culverts and arches, if they're large, may not be readily available in a short period of time. Your aggregates, you want to think about getting them to where you're going to source those. Erosion control, woody debris, matting. Contractors, there's a bunch of different steps depending on the scope of your project. You want to make sure you are preparing your contractors for this as well. Execution, this is where I'm going to spend a little bit more time. We're going to go through some step-by-steps and some best management practices. So number one, when you're looking at executing a project, you'll want to review your approvals, ensure they're all in place. Make sure you have all your third-party notifications. Be aware of your ground disturbance, including pipelines and protocols, and of course, safety. Safety will be the number one step for all companies. Timing of your execution, you'll want to think about the time of year. If you're working in a COP restricted activity period, you want to take that into consideration. And then you'll want to think about the time of each task. So in this illustration, once we decide what time of year we're going to do the project, whether we're in the restricted activity period or not, we'll want to start talking about timing our tasks. Now you notice I have not put these in a specific order. I've based them all around ecology and fish removal. These may not happen in an exact order. It depends on your project and how you execute it. But these are some of the items you'll want to think about timing. You'll have your site execution plan. And I highly recommend a pre-job meeting. So reviewing your plans with all involved, making sure everybody understands your best management practices, ensure everybody knows your objectives. If you're doing a large scale project and you have contractors and ecologists, biologists, and surveyors, not everybody's going to understand exactly what you're doing. By meeting prior to your job, reviewing the plans, going for a site visit, can be very beneficial for everybody to become part of the solution. It also helps encourage people taking pride in their work, and because many will be learning this work as we go. Isolation. So when you go to isolation, is one of the first steps we need to discuss. You'll want to think about where you're going to place your isolation above and below. You want to make sure your isolation is effective. So picking the nice place in the creek to install your isolation, thinking about, are you far enough upstream from the dam? Keeping in mind you want to isolate the smallest area possible, and understanding where your pump suctions and discharge will go. Dams and diversions, again, location, where are you placing your dam? How deep is the water? How deep do you need the water to be? Your dam can be installed to make the water deep enough for your suctions on your pumps. Are you putting it in a place where the banks are consistent? Are we minimizing disturbance when we are installing our dams? I've got 3 pictures of dams. You can use sheet pile dams. Sheet pile dams are nice when you've got sediments on the upstream side of your crossing. When we talk about hanging crossings, a lot of times a fluvial creek may acquire sediment above the crossing. You can look at sandbag dams. I've got an aqua dam shown here. And we can also talk about diversions. In mining, forestry, or municipal work, sometimes if we're installing a large crossing, you may look at diverting a creek for a period of time. Pumps, so if you decide to go with the pump route, you need to think about the location of your pumps, the volume of flow that your pumps need to handle, the intake and discharge. So fish screens on your intake, monitoring your fish screens, your discharge, sediment and erosion issues. Do you want to, if you're pumping with an 8-inch pump, you'll want to make sure you are controlling your discharge so you're not affecting the creek downstream. Is your discharge above your downstream isolation? Seepage pumps are bell holes, so when you install your dams, a lot of times they may leak or seep. So how are you controlling that water from coming back into your excavation? Fuels and spills, you want to make sure your pumps are in a location where they're easy to fuel. We've got spill drip trays. Do you have spill kits in the area? Discharge hose, where are you placing your discharge hose compared to your excavation? So you're not blocking access from equipment coming to site. Backup pumps. There's 2 reasons for backup pumps. Is number 1, what if one of your pumps breaks down? So you need to have your backup pumps to handle water flow for that purpose. Flow variations. You could see a rainstorm, or if you're working in late fall and it snows, it gets warm during the day. So you want to understand that your pumps are capable of handling the volume, and also the duration. So if you're working on a smaller crossing, you may use some 4-inch gas pumps, and your planned excavation and restoration will be less than a day. Or are you dealing with large pumps, 8-inch diesel pumps, 6-inch diesel pumps that are going to be pumping around an excavation for a larger period of time? Fish salvage. So we've got our isolation in place, our dams in place, our pumps in place. We are now going to make sure we have time for our biologists to come in and help out with our fish salvage. They need time to do this. We may have set up traps prior to pumping to trap some of the species. They need the time to do their electroshocking properly. They may be netting if we've got large outlet pools. They have to collect their data, and they also need to complete information for their fish research license permit. Materials and access. If you are working on a crossing that you're going to be bringing aggregate in, or bridges in, or trees for your slope stabilization, you'll want to think about, is that on site ahead of time? How do we get at the site? What time do we need it? How are we going to deliver it? Are we using the right size of equipment? Do we have steep slopes going into the site? What's the volume of material that we need to bring to the site? Do we need access matting to access the site with this equipment? Slope disturbance and vegetation. So the less disturbance we have, the less erosion and sedimentation we have, the less area we have to revegetate. If we are disturbing vegetation, we can look at salvaging some of the vegetation for use later in our project. Temporary bridge installations. If you have a crossing that requires temporary access, you'll want to think about the location of the temporary bridge. Do you require workspace? Again, you want to try and minimize disturbance. What's the duration of the bridge that's going to be installed? What's the traffic requirement? Is this for large production or log hauls or mining, or is it just for pickup access? And you'll want to consider cleanup. Equipment. So the equipment you need on site can vary on the scope. You'll want to consider the size of equipment you need. Where is this equipment parking for fueling? Is this equipment free of any spills or leaks? And ground stability can play a factor as well. If you are working over steep banks, large equipment can cause stability issues. Excavation, so you've got a site plan. If you're excavating a site for a creek, for a culvert, your alignment might be straight. If you're doing a creek, it may be variable. The grade, you'll want to consider the inlet and outlet versus the stream characteristics. So if you're looking at the inlet and the outlet on a hanging culvert, it could be a 10% slope or a 2% slope, but if you go upstream or downstream of your creek, it may be a 1% slope. The width and consistency of your excavation. If you're doing a culvert, you'll want it to be nice and straight. If you're doing a creek, it can be variable. Your slopes are going to be different for a creek versus a restoration or a bridge, and you'll want to think about sediment control. Two things I want to highlight is if you're doing a large excavation, try not to overcut your slopes. So there's no point in excavating a slope and then filling it back in afterwards. That makes the slopes less stable. You'll also want to leave your slopes very rough and lumpy. If you've got nice smooth slopes, you may need to work with your excavator operator and equipment operators that are trained to make things look nice, to make it look natural. During the excavation process, you might find buried topsoil, trees, or natural stream beds. So you may find materials you have to remove from the site. Understanding your restoration plan. So now that your creek is excavated, you'll want to understand your restoration plan, what grade you have selected, the width, what is placed first. Can you do this as you excavate? You want to think about delivering your materials, revegetation and willow staking your slopes, and installing erosion bars. You may want to make sure you're installing erosion bars upstream of your creek while you're excavating your creeks. New crossings. So now that we've restored our creek, we can look at whether we're going to install a bridge or an alternative crossing or a culvert or an arch over our restored creek. Of course, with the arch and culvert, that will be done during the process. But again, this presentation is about restoration. Once we have excavated our creek and our restoration is complete, we are now going to reopen the creek. So reopening the creek, we have to make sure we are able to control the flow to flush the creek bed properly. We want to make sure we're able to control our sediments. This may take a couple hours, it may take a couple days. You'll also want to make sure as you are flushing your creek, you are maintaining flow downstream. So if you've got a large outlet pool and you've allowed your flow to go through your creek, your sediment water is going into your outlet pool, you are managing that water with an outlet pool pump to ensure sediment doesn't enter the creek. You also need to make sure you're maintaining creek flow to the original creek. So you're still have your pumps or your diverting a large portion of the water around the creek. Once your creek is clean and flushed, you can start with dam removal and isolation removal once the creek is flowing 100%. Slope management and site cleanup, you'll want to think about if this is your disturbed area and it is a steep slope and it's been freshly disturbed, do you want your water to be running directly down into your excavation? Not only have we decided to make sure our slopes are rough and lumpy, but we've also installed diversion bars or berms that are increasing the run of the water discharged into a well-vegetated area, decreasing grade and speed, and controlling water from entering disturbed areas. Erosion control can also be done with geosynthetics, such as silt fence, coconut cloth. There's a variety of options. Just ensure you have a proper slope management and site cleanup plan. I'm using this to show a bunch of these steps on a specific map. So this could be done in the planning process, but it's definitely part of your execution. So this shows an execution site plan. If we're going to put an order of a process, for purposes of this slide, we'll put it in an order. So we've checked, we make sure we have all our approvals in place. We have discussed our timing and understand when we're doing this work. We have a site restoration plan. We have met with all of our contractors to discuss the project. We are now looking at isolating our project. We're installing our dams. Our pump setup, including the route of the pump around to maintain access from our access point. Once this is all set up, we are going to dewater and defish our crossing. Again, we have our isolation upstream and downstream. So in this process, we have to make sure we give our biologists time to defish the site, whether we are trapping or electroshocking or netting. We are dewatering through our dewatering pumps. We have our equipment and materials organized. We have discussed which vegetation we are going to maintain. The vegetation here, perhaps we salvage. We have our equipment arriving on site. We are now completing our excavation. As we do our restoration, and when the site is, once our restoration is complete, we are now opening up our dam, allowing some water through our site. Our outlet pump is managing the sediment while maintaining water going around the site. When that is complete, we now do our site cleanup and our slope stabilization. Of course, you may have decided to install a new crossing as part of this execution as well. So it's an example of all the different steps, how you can put them in order. They may change order, but it shows it all on a specific site plan. Monitoring, I'll briefly touch on monitoring. So monitoring, once you've completed, of course, we've learned that fish habitat may take years. To measure success, we can look at reducing the number of red inventory we have over a year. That's a measurement of our success over time. And operationally, from a execution perspective, I'd like to note the importance of going back year for year. If you're responsible for completing a site, going back and seeing what worked, what didn't, how is that site year after year after spring melt off, large flood periods. That to me is very important. I like to go back and look at my sites after we've completed cleanups on them. In summary, I just want to bring up this number here. So 152, 228. That seems like a very huge number of fluvial crossings in Alberta. I don't think the number is 100% accurate, but we do know there's lots of issues out there. Start at step one. If we don't fix a crossing, that number is never going to drop. If you plan properly, prepare properly, keep it simple, we will all become more effective and efficient over time. I hope you found some value in that. I thank everybody for their time, and if you have any questions, you can reach me at acornenviroinc@gmail.com.
Thank you, Steve. That was great, very informative. So now we'll move on to the question and answer period. If anyone has any questions, please submit them through the GoToWebinar toolbar on the side. We've received one question so far, but just to give people a bit of time to answer or to ask the questions that they want answered, Steve has a little video that he wanted to show. So he can just put that up and we'll go through that while people submit their questions.
Thank you, Daniel. So this is a video, a time-lapse video of an excavation. I just found it might be interesting to some to actually see the process live. So I'll narrate this briefly as we go. So we've got our pumps set up. Again, the execution may happen multiple orders. So we've got I'm just gonna let this play. So we got creek crossing with hanging culverts. We've identified the problem. We've got our pump set up. We've got an outlet pump. And we are starting our excavation. So sorry, I'll slow down a little bit here. Our pumps are set up upstream. They are diverting water around here, around this side, away from our access. We are lowering the water in our outlet pool. Of course, our isolation and defishing has already happened in this video. We've got backup pumps set up over here. You can tell our equipment is fairly large for this crossing. To try and minimize disturbance, we have decided to remove the material from the site. So we've used a rock truck to remove it. In this portion of the video, the crossing has already been removed. Obviously, our water's gone. We are getting down to a grade that we suspect or we planned based on measuring our creek characteristics upstream and downstream. One thing you'll notice in this is as we excavate, we actually start finding a native creek bed. One thing I missed in my presentation is when we are doing creek excavations, again, it's not important. It's more important to be rough and lumpy and have an undulation in creek restoration that is smooth. So in the last clip, we were actually creating a little channel in the creek bottom. In this video, again, you can see our backup pumps on the right. This is our seepage pump, pumping water back up the dam. Obviously, we've got our aggregates and our creek bed materials behind the excavator, so it's quick and easy to deliver. We're not waiting for aggregate to show up on site. We have 2 people on site that are measuring and giving direction. We've got our creek restoration plan that we have our riprap on the sides. We've got our large culvert on the bottom. We are now placing our larger aggregates for creek characteristics. We are getting close to completing the creek rebuild. Again, our outlet pump is ready to go. So once we decide to open up this creek, instead of letting the water flush down to the creek, we are going to manage it with our outlet pump. The outlet pump runs over this hill to a well-vegetated area, so our sediment is not discharging into our creek below stream. So you'll notice a lot of communication in this video. Many times we will be working with a variety of experience. So our excavator operator may have only installed culverts for years. In this portion of the video, you can tell our creek is rebuilt. We've decided to open up the water. We are letting it flow slowly. And within a short period of time, this particular crossing was a couple hours, we found our water very clear. So we started opening up the flow, removing the dam, removing the isolations, and this is the result of our crossing. Once our creek is rebuilt, we have some flow. We decided to install some woody features over top. You'll notice on the right, we actually have a berm at the top of the slope to prevent water from entering here. It can be diverted to enter where it's more vegetated to prevent erosion, and we've willow staked our slopes as well.
Great, Steve. That was a great video to visualize the whole process. So we do have a few questions that have come in, so I guess we'll just jump right into those. Just so everyone knows, something I've been saying at every webinar, but it may be your first. We're going to try to limit the total time of the webinar to 1 hour. So if we reach the 2 o'clock mark, we'll cut the question and answer period. But if we haven't gotten to your question that you've asked, these questions will be distributed later on. So a transcript of the questions will be distributed by email. So if we don't have time to get to your question, we will get to it eventually. So Steve, the first question here, when you do your LiDAR modeling, how does it come up with a Q25, Q50, and Q100 flood modeling? So I don't know if you're the best person to answer that, or maybe Bruce wants to step in.
Sure.
Thanks, Bruce.
So essentially, just through processing the LiDAR, first of all, you have to acquire LiDAR for the area, but just using a GIS system like Esri or others, you delineate watershed area. And then from that, we use different mathematical equations and come up with provincial flow data to come up with peak flows for the area. And from your inventory, you understand the creek dynamics at the crossing. So you're able to determine what what an estimated 1 in 25 year flood event would look like. Lots of people are skipping the 1 in 25 and going to a 1 in 50, which is above and beyond what's asked. And people are considering a 1 in 100 year flood event even right now. Hope that answers that.
Yeah, thanks, Bruce. So the next question, do you tender out all crossing projects to a group, or do you directly award projects? How do you know if a contractor is knowledgeable about all of these practices?
I can take this one. So part of my role is addressing issues like this. So it depends on the project and the scope and scale. There are very few contractors that have high extensive knowledge in working in and around streams. So what I find is it's always nice. The best way to approach this is think about putting the best team together. So this may involve ecologists or contractors. Ensuring operators understand the desired outcome is very important and often requires working with specific people that have experience. So to back up, depends on your project. You may be able to find a contractor to handle the full scope for you. However, if your contract's very extensive, you may need to hire contractors and build a team to work together on that crossing.
Great, thanks. Move on to the next question. Do you need the ecologist on site for the whole time of the operations, or only at the beginning and end of the project? So Steve, maybe you can take that one too.
Sure. No, most of the time you do not. They are needed prior to operations to ensure fish are salvaged properly and the work site is isolated, and during the initial dewatering to do a final sweep for fish, depending on the complexity of the project.
Okay, great. So when the slope is excavated in a rough shape, as mentioned during the presentation, will it create additional challenges to ensure proper compaction during backfilling?
So this question I will take. If we're talking about excavation for so I'm going to break this into two parts. So if we've got a slope on a restoration program, the rough and lumpy, uneven sloping is for the purpose of decreasing erosion, revegetation. If we're talking about backfilling, I'm assuming we are discussing a culvert. So if we've done an excavation and we're going to do a culvert or a bridge, abutments, or an arch, in that case, wherever you're backfilling, you would probably not leave it rough and lumpy. So if you've got a compaction spec, we're talking about leaving slopes of vegetation near the creek. We're not talking about backfilling over a specific crossing like an arch or a culvert.
All right, great, thank you. So next question, can crossing remediations be done year-round? What is the best time of year to undergo one of these projects?
So crossings, they can, but that doesn't mean they should. You have to consider restricted activity periods as per the COP. You also want to think about if you are doing excavation in the winter and you're dealing with a lot of frozen material. Frozen material is difficult to work with, or same as the previous question for backfilling. If you're backfilling on slopes, it's not good to use frozen material on slopes. The best time of year is usually the late summer or the fall during low flows. And you also want to consider spring runoff, rain events. So you can, but it does not mean they should.
All right, thanks. Sorry, I've lost my place here. Just 1 second. Okay, so why do downstream isolation? If you're properly isolating upstream and allow for reasonable space for the work area, why do you require downstream isolation?
Downstream isolation is not always needed, but sometimes gives site layout the bypass. Sorry. It's not always needed, but sometimes gives site layout the bypass. Output is very close to the work site and isolation can be needed. So, Bruce, do you want to step in on this one? Sorry.
Yeah, it totally depends on the site that you're working at. So if you, generally if it's a larger, deeper creek, you have your output coming in close to the work site. So you're gonna have the possibility of fish getting up there. And it's very nice to have the security knowing if you get peak flows or anything, that there's no way fish can get into your work site. So it's totally site specific. There's some places where isolation is one simple fence, and there's some places where isolation is a series of 3 or 4 fences above and a couple below. So I'll actually speak of that in about a month when I do a different talk.
Yeah, thanks, Bruce. I got a question that has a pretty quick answer that I can just give out right now. Somebody asked for Steve's email address again. So it's acornenviroinc@gmail.com. I actually just sent it out in the chat to all audience members. So if you click on the chat on the side there, you should have his email address available to you. So the next question in the list here. When flushing the isolation after the work is complete, what is the suggested proportion of flush water versus diversion flow?
So I can handle this question. It's going to vary per site, but you want to ensure you maintain downstream flow during the flush process. So if you're diverting with 2 4-inch water pumps and they're both running at 100% capacity, you'll want to make sure you maintain flow downstream for potential habitat downstream. When you start flowing your creek, you may do it with a pump or start opening up your dam. You're going to want to start slowly. I suggest raising that, increasing that flow so that you can cover your entire creek bed. You'll want to make sure you flush the whole site prior to opening up to 100%. And it also depends on your outlet pool. So if your outlet pool is a large outlet pool that may take a couple hours to fill, or you'll want to start slowly, increase flow to flush the entire site. Once your outlet pool's clean and you are able to allow that flow to flow back into the creek, then you can look at going back to 100% flow.
All right, great. Thanks, Steve. So next question is about turbidity monitoring. So it says that you don't mention conducting turbidity monitoring during construction to ensure mitigation measures are operating properly. Is this not needed? So is that a requirement on site, turbidity monitoring?
Bruce, I'll let you take this one. Yeah.
I can jump in if you like. It's not always required. Often in-stream works where you're not dewatering a site, it's prescribed and you conduct it. But once you start a project, the idea with turbidity monitoring is if you reach a certain threshold, you would stop and allow that turbidity to decrease. For most of these projects and what Steve did, the sites were dewatered, and you're not going to stop this project. It's going to go forward. The turbidity's in the dewatering and flushing out the creek that he spoke of.
All right, thanks, Bruce. So it's sometimes hard to tell what size pumps and hoses that you need at a site. Do you have any tips on how to predict the size of pumps that you will need?
So pumps, I would strictly calculate the flow of the creek. You can use, there's a variety of ways of calculating the flow. You can also do trial and error, which I don't recommend. But yeah, calculating the flow of the creek. As far as the hoses, that'll depend on your site plan. It's nice to draw all these processes or these steps out so you understand how much hose you need as well.
Yeah, thanks, Steve. I guess another thing that's just mentioned, I see that someone made a comment here, is to always be prepared for more flow than less.
Absolutely.
Which I think is a good tip.
Actually, one other thing I want to talk about pumps is monitoring your suction is extremely important. When you have pumps in a creek, there are a lot of times the suctions will plug up. So you may think your pump is not keeping up to the flow, but if you keep your suctions clean, it'll keep up to the flow.
All right, great, thanks. This one's about the cost of what it costs to do a restoration like this. So just asking for kind of a ballpark of what it would cost to do a restoration project like this.
It could be extremely variable. It depends greatly on a variety of things. So when you say this project, if you're doing one crossing, I guess the one comment I would make is if you're going to go into an area and do one crossing, if you can group it into a larger project, the cost per project will become less due to being more efficient at working in an area and becoming more efficient contractor. But each project's going to vary drastically.
Yeah, that makes sense. So in your example video, why was aggregate brought in after the native cobble stream bed was exposed?
So in the video that we showed, we're not sure if we'd find the original creek bed or not. Lots of these crossings, you won't know that until you actually start digging. So on that particular site, we had aggregate there in case we needed it. And that happened to be our last crossing, and we had the aggregate there, so we installed it as well.
Okay, great. Just to give everybody a heads up, we're coming up on that 1 hour mark, so we'll answer a couple more questions, and then if anybody has more questions that they would like answered, we'll add those and they'll be answered and distributed later. So the next question is, in your experience, when has been the best time of year to do crossing construction? Which I guess you've kind of touched on already. But
yeah, typically in the fall, late summer, fall, low water flows, stable weather, and you'll also want to take into consideration your restricted activity periods for these crossings you're working on.
Right. So when reclaiming a crossing, what is the best material to use for restoring the stream bed?
It's going to depend on your crossing. It's nice to use native material. If you knew you were going to find a native creek bed, that's ideal. If you're going to import material, it depends on your restoration plan. For smaller crossings, less flow, the aggregate might be smaller. If it's a larger crossing where you install features, you're going to be importing large class 5 riprap. For vegetation, ideally native. If you can salvage trees off your slopes, use common willow stakes from the area. The more native material you can use, not only is it more cost effective, but it's also better for your crossing.
All right, great. Well, thanks, Steve. That's all the time that we have. So just a few comments here at the end. So I'd like to thank everybody who attended our webinar today, and we hope that you'll join us for some of the other presentations over the next 8 weeks. Our next webinar in the series will be taking place next Tuesday, May 5th at 1 p.m., where we'll have Michael Wagner speaking about sediment risk and road design. So if you enjoyed this webinar, I encourage you to have a look at the other webinars scheduled as part of the series on our GoToWebinar page or on the awccc.ca website, and register for some of those other presentations. So thank you again to Steve for presenting to us today, and I hope that to see all of you attending some more of these webinars in the future. Stay safe and have a great day.